So what we're looking at is answering the evidence. Are the Bible and science compatible or diametrically opposed? Obviously, there's a lot of people who believe that they are separate or that one has to give way to the other. There's actually a lot of people who don't believe in God because of evolution, and we'll talk about certain things. Basically, that's what we're looking at. Evolution, the evolutionary theory, the Big Bang, all that kind of stuff, putting it all together to look at that, because there's a lot of people who look at the science and they say, I believe in science, I don't believe in God. Or one of the reasons I don't need the Bible, I believe in science, right? I believe in evidence. I don't believe in some book some old guys wrote a million years ago. And so that's what we're looking at, is answering the evidence. So first, the 4 questions that create our worldview. This is very important because this is what defines how we live our lives. This defines how we interact with other people. This also defines how we interpret different things. But we all seek to answer these questions, which is, number 1, who am I and what am I worth? Number 2, where did I come from? Number 3, why am I here? Number 4, what happens when I die? The way in which you answer these questions can define the way you live. Also, the way you live can help also define the way you answer these questions. We obviously answer these differently than someone who doesn't believe in God, or specifically the Christian God. Muslims might answer these questions differently. Atheists definitely answer these questions differently than us. But we all seek to answer these questions because we all want to know, why am I here? What's my purpose? Where am I going? Where did I come from? All those kinds of things. And so this study is not completely exhaustive. We're not going to look at every single piece of evidence, but we're going to look at a lot of the major ones, break them down. We're not trying to disprove science and uplift blind faith like some people may think. We're just saying this science is a certain thing. Science is data, and we'll look at that. But we're seeing how do we interpret that data, and how does that define the way we answer these questions. So this is Christopher Hitchens. Let's turn this just a little bit over this way. Okay, it's still a little bit off, but what can you do? So he says, our belief is not a belief. Our principles are not faith. We do not rely solely upon science and reason because these are necessary rather than sufficient factors. But we distrust anything that contradicts science or outrages reason. We may differ on many things, but what we respect is free inquiry, open-mindedness, and the pursuit of ideas for their own sake. Christopher Hitchens, he's an author. Well, he was. He passed away. But he was an author, journalist, educator, very prominent atheist, one of the foremost atheists of his time. Very respected man, very intelligent, if you ever heard him speak. But he was an atheist, and he says, I don't believe in faith, I believe in science. More specifically, though, what he says is that I believe anyone who speaks out against the science, right, the scientific evidence, I have no reason to trust what they say. Why should I believe what they say? Basically, there's a lot of, and this is kind of true, there are a lot of people who identify as Christians who say, I believe in God, and therefore I don't believe in science. I don't believe in the evidence. They'll discount the evidence, which is not something I think we should do. We shouldn't say, oh, I don't believe the evidence. It sounds contrary to what I believe. I'm going to go with this instead. If the Bible is true and God is true, then the evidence will not contradict God. So we should be able to answer that evidence. We shouldn't just shy it away and say, I don't want to look at it, because that's kind of like what cults do. That's kind of what people do when they have their own biases. They want to confirm their own biases. I want to believe this thing because it must be true, and they're afraid to look at something contrary to it. But we should be able to look at something contrary to it, because if what we believe is true, it will hold up against that which is contrary. So first we'll start off with, go back. The definition of science. So the systematic study of the structure and behavior of the physical and natural world through observation, experimentation, and the testing of theories against the evidence obtained. A lot of people will say science, and they kind of use it synonymously with scientists. That is, scientists say this, and they'll say, well, that's what the science says. That's what the science says. Science doesn't say anything. Science is just like observation, evidence, testing. It's data. Data doesn't speak. Data doesn't interpret. Data just is. And so science is just something that is. It's a way we look at stuff. It's how we interpret stuff, but it's not interpretation itself. That's one thing to know. The other thing is the definition of faith. Now, this is not something you'll find on Google. Google will not give you a good definition of faith. This is more akin to the definition of trust, which is what faith is. A lot of people think they're contrary, they're separate, but faith and trust are literally synonyms. If people just knew that, they would understand why we have faith more so than they think it's blind faith. But the way I define it is complete trust or confidence in what is yet to be observed in someone or something based on previous observations which have confirmed that trust. It cannot be proven because it has not yet happened, but it does grant good reason to believe it will. That is, I believe this thing will happen based on observations I've made of it happening in the past, which we can see how that ties in with science. That's literally what science is. Science makes theories, they make hypotheses, and they see, oh, do those observations line up? And can we prove those observations later on? You can't prove it because it hasn't happened yet, but you have good reason to believe it will happen. We can see how faith and science can go hand in hand. The question is not so much, can faith and science agree? Can God and science agree? The question is, do we agree? Does the evidence agree, right? It's not just, does our interpretation agree? It's the data. What does the data say? Does it agree with God or does it agree with what scientists say? And that's what we're going to be looking at. This is Richard Dawkins. He's still around, and he's I think he's a biologist, evolutionary biologist. And he says it is absolutely safe to say that if you meet somebody who claims not to believe in evolution, that person is either ignorant, stupid, or insane, or wicked. But I'd rather not consider that. And this is kind of the position of many pop atheists, is what people call them. Very famous people. That one comedian, that British comedian, I forget his name, very famous. He's also like that. Yeah, here everyone's trying to think about it. I don't remember his name. But he's like this also. He thinks it's silly, it's dumb. How could you ever possibly believe in that? If you don't believe in evolution, you're stupid. Because the evidence proves evolution, that's what they say. And so there's a lot of people who actually are Christians and believe in the Bible, and they say, oh, I believe in it with evolution. And that's kind of what we're going to look at when we look at the evidence. Can they go hand in hand? Are they contrary, or are we just interpreting one of them or the other incorrectly? And another thing to note before we go on, people are fallible. So even though the data may say something, people can make mistakes. They can misinterpret the data, either on purpose or on accident. If we all do that. We know we do stuff like that. Oh, I made a mistake. How did you make that mistake? It just happens. It doesn't matter how smart you are. It doesn't matter how uneducated you are or educated you are. You can make mistakes. You are possible to have your own biases, and we see that with a lot of people who get caught up doing certain things, and then you find out, oh, you're actually in the wrong, whether they knew or didn't. Everyone is capable of being incorrect. So these are the 5 things. Right now we're just kind of summarizing what we will be looking at. We have a lot to look at. We won't cover it all today. But this is the 5 things that we'll look at. So this is not necessarily the theory of evolution, but when people talk about evolution, they tend to lump all these together. So it's really the model of the Big Bang, which kind of ties into cosmic evolution, and then abiogenesis, microevolution, and macroevolution are all part of the theory of evolution. But we'll call it all together because everyone kind of lumps it all together. And so we're going to break these things down individually, and we're going to start with the Big Bang, then move on into cosmic evolution, abiogenesis, which is life from non-life, microevolution, that's adaptation, and macroevolution, that's the big scale stuff, the reptiles into mammals and things like that. And so we're going to probably only get to the Big Bang today. And if you guys want to continue, we'll look at the other ones later on. But this is kind of what we look at when we think about evolution, right? We all came from vertebrae, and then they start to get bony skeletons. They start to form 4 limbs, amniotic eggs, hair, 2 post-orbital, all that kind of, gobbledygook scientific terms. But basically, we went from single-celled organisms to more complex organisms that could give live birth, that could give birth to eggs, that could fly, that could breathe on land, all that kind of stuff. It all kind of stems from one common ancestor. We all stem from a common ancestor based on the evolutionary theory. Or the model. So this is obviously a very artistic rendering of the universe. And so with, let's put this down. The accepted age of the universe, does anybody know what the scientific accepted age of the universe is? This is what they call the accepted age of the universe, would be what most top scientists accept as the age of the universe. Does anybody know? Yeah, close. It's 13.7 billion years. I'll put that down here. That way we have it visible. 13.7 billion years. That's the accepted age of the universe. I'll put it right here. Universe. Does anyone know the accepted age of the Earth? I forget what it was. 4.5. Jason's an evolutionist. Very interesting. All right. Oh, there's missing a letter right there. Okay. This is important to look at because we're going to define why people believe this. It's not just a random number that people hold to for no reason. There is a reason behind it. And so this is the two different accounts. And we'll get into more reasons why they look at those things. But these are the 2 different accounts, basically. So you have the evolutionary account and the biblical account. We'll start with the biblical side. God, in the first day, God creates outer space, earth, and light. On the second day, he creates the sky to separate the watery earth. On the third day, he creates dry land and plant life. On the fourth day, he creates the sun and the moon to set over the earth. On the 5th day, he creates flying creatures and sea creatures. And on the 6th day, he creates land animals, insects, and mankind. Now, these are not synonymous in terms of the days, or they don't correlate that way. This is just kind of the order in which it occurs in the Bible. This is the order of which it occurs according to the evolutionary account. So according to evolution, it's outer space is created in the Big Bang. Then you have the formation of Earth. Then on Earth, you have the crustaceans, which become fish. The fish become reptiles. The reptiles become birds and mammals. And some of the mammals go back into the water, making whales, dolphins, killer whales, that kind of stuff. And then you get to the very end, which eventually we get the ancestors that became apes and humans. And no, they don't believe that humans came from apes. They believe that humans and apes came from a common ancestor, that we split off and eventually we became more evolved, they became less evolved, or they stayed at the same evolutionary area. Let's go to the next one. Too many things to be going through right now. This is really cool, I think. Can we turn the lights off lower so we can see this a little bit better? Let's turn this a little bit faster. This is the scale, if you can see how much I'm struggling right now. No, go up. It lasts so long, I'm just trying to, no, maybe not. Well. Oh, I was so close. Look at this. This is the moment we all been waiting for. Okay, it's a long video. But basically, this is showing the observable universe. Is it going fast? Yeah. So that's the Earth, obviously. Look how small we've already become. Think about how small humans are on that. You're going to see a little ball. That's the moon. It's very far from the Earth, if you didn't know. That's the course. The green area is our orbit around the sun. It's playing a little music, if you can hear it. But. And that's zooming out. That's our solar system. Again, showing how small our Earth is. It's going to disappear soon enough. Going out, again, our solar system, the farthest one out there, I think, is Uranus or Neptune, one of those. They don't show Pluto. That's our little solar system zooming out. Oh, now you can hear the music. We're going to be zooming out soon to the Milky Way galaxy. That's what we see the Milky Way galaxy in terms of what we look at. So you can't even see our solar system anymore. It's just, and these little dots, you think they're probably stars, but most of these are actually little solar systems because by the time you get that far out. So that's our Milky Way galaxy as we're zooming out past that. Again, just insanely large. And as we zoom past that, we're getting to what's called the local group of galaxies. So not just the Milky Way galaxy, but you're going to start seeing around it little other galaxies. Again, which in those galaxies you have multiple solar systems having multiple planets and things like that. You see one close by to us. Zooming out past that, we have what's called the Virgo supercluster, which is formed up of multiple galaxies that are clustered together. So you have multiple galaxies clustered into this giant cluster called the Virgo supercluster. And that's what we're seeing right now, the Virgo supercluster, as it zooms out. And zooming out even more, we see the Pisces-Cetus supercluster complex. That is this giant cluster formed up of many clusters that have smaller clusters within those clusters that form galaxies, solar systems. Zooming out past that, now we're getting to the observable universe, just going all the way back into something that's so uncomprehensibly large that you can't even fathom. I mean, these are not stars. Again, these are not stars. These are not even galaxies. These are not even superclusters. They're complexes of superclusters. That's just how insanely vast and massive it is, which is insane. Thank you. Yeah, I think I have to go. Yeah. Where isn't it? Let's see if I can get past that. Don't play it again, please. Okay. You can't see it getting cut off, but that's the observable universe. So like I mentioned, there's the Pisces-Cetus supercluster complex. Within that is the Virgo supercluster. So here, and then you can't really see, there's a little tiny line. So there's a tiny little dot that you cannot see, which is not Earth. It's not the solar system. It's not the galaxy. It's not even the galaxy which all the galaxies connect together. It's the supercluster that holds those galaxies. So that's what this tiny little dot is. The supercluster that holds the galaxies, that holds our galaxy, that holds our solar system, that holds our planet, which we are on. We're insanely tiny, infinitesimally small. Just to give you an idea of what we're talking about when we say, why is it that we look at these things and why do people are so interested in that? Because that's what we are in terms of the observable. And this is the observable universe. There might be more that we cannot see based on our telescopes and our satellites going outwards and all that kind of stuff. And this is kind of obviously a generalization. We don't know exactly the form of the universe, but this is kind of how they show it. This is a good quote I love. That's by Abraham Lincoln. It says, I can see how it might be possible for a man to look down upon the earth and be an atheist, but I cannot conceive how a man could look up into the heavens and say there is no God. I think when you look at something as large as that, you think, it's just unfathomable. How can this even occur? And especially when you think about the fact that we're that tiny dot within a tiny dot within a tiny dot within a tiny dot within a tiny dot. And that's us. And yet you have this giant thing of existence. You think how worthless we are, and yet how important we are, and how there's no life anywhere else. We've never seen life anywhere. Out of all the observable universe, we've looked for other planets. We say, oh, this planet could be habitable, but it contains no life. And that's all we see. And we think there's actually more and more people thinking now that we will never find life. Because the more we look out, the more we don't find it. The more we look out, the more we don't find it. There's a lot of people who are still hopeful they want to see aliens. But it seems most likely, no, we will not. Which is very interesting. Why, again, why are we here then? What's so important about us that we are here and there's nothing else anywhere else in the world? In the universe, sorry. Let's get now into the Big Bang, right? That was all just the intro. Woohoo. There's a lot. This is why I have all this stuff, because it's a lot of stuff to get through. So the Big Bang Theory says that the universe came into being from a single, unimaginably hot and dense point, also known as a singularity, more than 13 billion years ago. It didn't occur in an already existing space. Rather, it initiated the expansion and cooling of space itself. That is, the way they describe it is a period on your page. That's basically all of space, time, and matter contained within that. Very, very tiny. Like all things that we just saw in the observable universe, all contained into that. No space between atoms, just everything contained in this dense, hot thing that exploded outward, and that's what we call the Big Bang. They also say that the universe has not existed forever. It was born around 13.82 billion years ago. Matter, energy, space, and time erupted into being in a fireball called the Big Bang. It expanded, and from the cooling debris, there congealed galaxies, islands of stars, of which our Milky Way is one, among about 2 trillion. Is it going? Oh, that's wonderful. Oh, I'm going to skipping ahead. Yes, it is. Spoiler. Yeah, so it's obviously, so the Big Bang explodes outwards and everything starts to explode and starts to cool down. The best way to look at it is this hot ball of energy explodes outward and all the matter, space-time goes out. As it goes out, it starts to spin. As it's spinning, it starts to cool down. It starts to cluster different areas. So you have these galaxy clusters, and then you start to have matter cluster into planets and stars and things like that. And as it does that, it cools down, and then we get down. Later on, we'll see how it affects Earth, where the water rains on the rocks and chemical soup and all that kind of stuff for the first life. But of course, the question is, what's the mechanism? What caused this Big Bang? Obviously, what banged, right? Something banged, something exploded. What caused it? How did it occur? This is what Stephen Hawking says. Because there's a law such as gravity, the universe can and will create itself from nothing. Spontaneous creation is the reason there is something rather than nothing, why the universe exists, why we exist. It is not necessary to invoke God to set the universe going. That's what Stephen Hawking says. He did pass away, and he did pass away as an atheist. He did not believe in God. He said there's no reason to believe in God. That gravity can be the order. We don't need order from chaos with God. Gravity is kind of the reason that we see order from chaos. We'll get into that a little bit, what he's trying to say. But yes, that's what he believes. That's what a lot of people believe. We don't need it. The laws are what formed the order. We don't need God to make those laws. This is what we'd call, this is just an artistic rendering of the quantum vacuum. That's kind of, what's the mechanism? What caused this? Where did it come from? This is one of the ideas they have. So the quantum vacuum has been described as a ghostly presence, a source of infinite potential, and a gateway to the unknown. It's believed to be the origin of the universe, and it is thought to be the source of dark energy and dark matter. We'll get into those much later. The quantum vacuum is the state of absolute nothingness that exists between particles at the quantum level. It is a realm of pure emptiness, with no particles or energy present. In classical mechanics, the vacuum is nothingness. Now, notice that little thing on the bottom. It says, in contrast, the vacuum of quantum mechanics is a pure, uncontrolled energy. So their idea is that because at the quantum level, things pop in and out of existence, therefore, the universe can pop in and out of existence. Maybe the universe existed at that quantum level, and it just exploded out of existence. But you notice that little thing at the bottom. In contrast, the vacuum of quantum mechanics is pure, uncontrolled energy. It's not a pure vacuum, like this one says right above it. In classical mechanics, a pure vacuum is nothingness. Yet in quantum mechanics, it's energy. Yet some people will say that the Big Bang came from nothing, or these things are popping in and out from nothing. But when they really say nothing, they're actually meaning something, which is, I think, silly. This is David Albert. He is a philosopher who combats those ideas that people have. Whether he believes in Christianity or not, I don't think so, but he definitely does not believe in the nothingness of the quantum vacuum. He says, and the fact that particles can pop in and out of existence over time as those fields rearrange themselves is not a whit more mysterious than the fact that this thing keeps on turning off. I'm sure next time it'll all be figured out. Over time, as those fields rearrange themselves, is not a whit more mysterious than the fact that fists can pop in and out of existence over time as my fingers rearrange themselves. And none of these poppings, if you look at them aright, amount to anything even remotely in the neighborhood of a creation from nothing. That is the idea that there's no fist right here. Now there's a fist. It came from nowhere. It didn't come from nowhere. Obviously, my fingers formed into it. That's what it is. So you see all this energy from trying to observe it. It looks like it's coming from nowhere, but it's energy all over, and that energy starts to come together, and it forms something. And then it goes out again. So it looks like it's popping in and out of existence. But it's not. Again, looking at that last quote, we talked about quantum energy. It's everywhere. It's energy that's forming these particles. It's not coming from nothing. Just to put that out of the way. So some people may say that the Big Bang comes from nothing. Oh, we don't need anything else. It doesn't have to come from somewhere. It comes from nothing. It comes from something. That is the quantum vacuum, which there's energy. The question is, where did that energy come from, and why did it create? You have to answer at least one or both of those. Well, you have to answer both of them, actually. So that's the question. This is our response, obviously. Psalm 90, verse 2. Before the mountains were brought forth, or ever thou hadst formed the earth and the world, even from everlasting to everlasting, thou art God. Where did it come from? God. God always existed. And so God can cause it into being. God can create it. And the reason we say God, and some other people will say, well, what created God and what created this? The issue is, if the quantum vacuum always existed, if that energy always existed, in eternity past, and it never created, it cannot create now. Because it had infinity options, an infinite amount of options to create, it never did. Now it suddenly creates? That's strange. But what can do that? What can not create and suddenly create? Anybody have an idea? A creator, a being, someone or something with a will. If it's a thing with a will, then we'd say it's a someone, right? Someone who has the ability to always exist, never create, and suddenly change their mind. It doesn't answer why they changed their mind, but it knows it's possible. It's not possible if it's just random processes, because those random processes happened for an infinite past and never created anything. So they can't just suddenly create, because all the infinite options said no creation. It can't change now. But if someone existed, they have a will, then they can suddenly say, I want to create something now. Even though I never did, now I want to. Doesn't explain why again, but it shows that that's the only possibility. That's one of the reasons we can have a confidence that a God exists. Doesn't mean it's necessarily our God, but it's definitely a God, someone, a higher being, a higher power. And we'll get into why we believe it's God later, our God. But here's an objection that people may have. You might have heard this. It kind of ties into multiversal theory a little bit, but it's the idea of an ever-expanding and contracting universe. It's called, the conformal cyclical cosmology. It's the idea that, so this is basically showing the timeline of the universe. It just continues down this way, and this is what's really going on. So it expands outward into infinitely expansion, and then it turns off. And then we're done, okay. But it expands outward infinitely, and then it contracts down infinitely. And it expands outward infinitely and contracts infinitely, so it's an infinite, it's the Big Bang to a Big Crunch. Big Bang, Big Crunch, that's kind of the idea of it. The issue with this is maybe the universe always existed in just constant states of being created and not being created, not being created. Which, I mean, maybe something has to exist infinitely. God exists infinitely. How does that make sense? It's hard for us to understand. So maybe it's possible this could happen, even though we don't necessarily understand it. One of the big issues with this, though, is the fact that our universe is expanding very rapidly. In fact, it's actually increasing in the speed at which it expands. It means it's going faster outwards than it goes inwards, which means it's very hard for it to go, if it's increasing in speed, it's almost impossible that it's going to come back to a big crunch. It just doesn't seem likely. Something would be left out, which doesn't make sense. It wouldn't be working that way. The other thing is that it also hinges on things like photon decay and Hawking radiation, which have never been observed. They're mathematical theories. They seem to be plausible when you use them in mathematics, but we have no reason to believe that they actually exist. So right now, this is not even a theory. It's not a law. It's not a hypothesis. It's a speculative hypothesis. It's very low on the bar. Not that many people are considering it. They think it's interesting, obviously, but not many people are holding to it because it has some holes in it that needs further data that they may never get. The other thing is morality. This is a big one for the origin of the universe. If the universe came from quantum energy, if it always existed, that kind of stuff, where does morality come from? That's the question we have to ask, because we know there's morality, right? We all agree there's morality. But you start to talk to people, where did the morality come from? Some people will say, well, we decided it. Some people say society does it, or it's each individual, governments, or a lot of people, I think Richard Dawkins and Christopher Hitchens both popularized this idea that it's evolutionary. We did it in order to form better relationships, or for survival, right? That in order to survive, we became kind to each other. In order to survive, we didn't kill each other. In order to survive, we didn't lie to each other, that kind of stuff. It formed evolutionarily. The issue with that is it formed, which means if morality formed, it's not objective, it's subjective. It's malleable, it can change. And if it can change, then it's not set in stone. Yet we know certain things, and I always use this example because it's a very extreme example, but it's an example we all agree is wrong under every circumstance, which is rape. In order for rape to be wrong in every circumstance, it must be objective. In order for it to be objective, it must always have been objectively wrong. The only way that can be possible is if morality has always been existent, if objective morality always existed. But the universe has no morality. The universe doesn't have any kind of will. The universe just exists, just like a rock. A rock doesn't know right from wrong. A rock doesn't know anything. A rock just exists. It has no morality. Morality has to come from a person, which has to come from something that has a will, which is what it creates. So in order to have any of this stuff, whether later on we'll look at all the other evidence for things. There it goes off again. But at least when it comes to the origin of the universe, it has to come from God in order for us to have objective morality, and it has to come from God because there has to be something that always existed, never created, and suddenly created. If not, then you don't have the universe as it exists, and you definitely don't have morality, which then, how do you explain morality? Oh, well, we decide rape is wrong, so you can decide it's not? Then that's what you have to, I've talked to people that admitted that, yeah, then I guess it's not. That's crazy. How can you say, because that's where the line, either you go that way, and you keep your line of thinking, or you have to change. Nobody wants to change. Even us here, some of us might be like, oh, I don't want to look at the evidence for evolution because I don't want to change my mind. But the truth is true no matter what. You either follow the truth or you follow your own line of reasoning, even to the point of error, where you're willing to admit something like rape is okay, which we should never do. Don't fall into that error, obviously. So that's the Big Bang. We'll continue on to cosmic evolution, which will kind of tie into the Big Bang also. We'll talk about some things like that. So the question is, how do we determine the age of the universe, right? That's what we're wondering. 13.7 billion years. Who came up with that idea? Does anybody know where we got that idea? Why do we think the universe is 13.7 billion years old? So someone just came up with it and just said, I'm going to pick a number?
Looking at the rate of speed of expansion and seeing how far back it would have to be.
Yes, that's one way. The expansion of the universe, so the universe, right, the Big Bang, that one singular point, shoots everything outwards, and it expands at a certain rate. Based on that rate, if we go backwards, we should be able to find out at least approximately how old it is, right? That's an approximation. It's the accepted age of the universe. It could be older, it could be younger, give or take, 100 million years, whatever they say. But that's where we get it. That's one way we get it from, is from the expansion, just working backwards. Another thing is the speed of light, right? The speed of light is a constant rate based on how far the farthest star is within our observable universe. How long would it take for that light to travel to where we are? At least you can get some kind of estimate based on that. The other thing is we look at cosmic background radiation, and you can see like stuff with that with heat and how much heat is dissipated and all that kind of stuff. It must have been super hot when it exploded, so if we can find out that most hottest point and all that kind of stuff. And based on if it's in the past, we see light from the past, right? The light from those stars is what they say, right? It came from there, so these stars could no longer exist, but we're still seeing that light because it's taking so long for it to travel, for it to finally stop traveling, then it'll go out of existence. So there's things like that. That's how they look at it. So basically stars is the biggest one for number one. Number two, if it will go. I think that went, there we go. So this is the stars. This is one way we look at it. So right here you have, will come in handy later on. This is our blue giants, and they are extremely hot. So this is how bright they shine, and this is the least hot to the most hot. So this is the brightest and the most hot. It also burns up the most quickly. So these ones don't exist for very long. They burn up because they're so hot, they're so luminous, and they eventually start to dissipate and become like this, and they end up turning into white dwarfs. And then we have stars like our star, the sun, which is yellow in between that area. Not too hot, not too cold, just right? That's interesting. And then you have giants over there. They're very luminous, but it's only because they're so big. They're actually not luminous by themselves. They're red, and that's kind of where our sun is going. It's going to slowly turn orange, then turn red, and, well, it all explode, 5.5 billion years later or something like that. So that's kind of one way to look at it. You can observe how long they've gone based on where they are in the life cycle, right? If we find stars right here, well, then they must have been over here. or somewhere around here, and then they slowly become this area that we can say, okay, it must take this long for that to happen based on the rate at which it burns, and the rate this thing turns off. And that's how we can find that. So it says the star's mass tells us how much fuel the star had when it was born, and the star's brightness tells us how fast it burns. It was burning that fuel. So that's one way we can look at it. The other one is by measuring the rate of expansion of the universe and working backwards, like Brother Jason said. And so they basically just look at it. Oh, well, it shoots out this way. Let's go backwards this way, and that kind of self-explanatory. Let's go on. So how do we respond to that? That's the question, obviously. Isaiah 42, verse 5. Thus saith God the Lord, he that created the heavens and stretched them out, he that spread forth the earth and that which cometh out of it, he that giveth breath unto the people upon it, and spirit to them that walk therein. Obviously, what we say is that God created it. God stretched it out. One thing to look at, and it seems like stars, if stars, like this star right here, let's say that's us, and let's say this star all the way over here is, 500 billion light years away. In order for that light to travel here, that's going to take forever. So the universe must be at least 13.7 billion years old. Yet if God creates everything at one singular point, and he says, let there be light, and he stretches out the heavens, that light starts at the center, and it shoots outward, which means the light was already originating where you're observing it from. So if we're observing the light on Earth, it already started Earth, and God stretches it outwards. And then by stretching it outwards, the light was already there. So what seems to be billions and billions of years for it to get here, it actually happened in a day or in a moment, however, depending on how he created. He's stretching it out. Did he actually stretch it, or did he just say, whatever? But it stretched out, and so it seems like it has age, but it's actually very, very young. And that's something we'll look at with this. So does anybody know how old Adam and Eve were when they were created? No, nobody knows. But were they babies? Were they old, very old? Sister Helen old? No. They were adults. They were fully mature adults. That's all we know. We don't know exactly the age, somewhere between the 20s to the 30s maybe, depending on ages back then. Maybe they're in their 50s, 60s, depending, they lived on for so long. Who knows when the maturity rate was. But we know that they're fully mature humans that had intelligence, they could talk, they could reason. They had everything that adults have to learn to get, and they had it as soon as they were created. So what it looks like, we would say, it must have took 30-something years for them to get at that age, but really happened in a day. God just created them. Same thing with the trees. This tree, based on how many rings it has, it took this long to grow. And that size, it's that long. It must have been hundreds of years for that thing to grow. The mountains. And in order for the mountains to form from the bottom up to the top, from the oceans, that kind of stuff, all the way up to the sky, that must have took millions and millions of years. But God created it that way, instantaneously. So it's something we call built-in age. It appears to be old. That's because God created it at a certain level of maturity. So it already was like that. These stars, they're already red. They must have been, burning. Well, God made it that way. He already said it in that life cycle. I love that. So he already said it in that life cycle, so we don't have to think, it must be this way. Again, one thing to look at, this is all the same data. We're all looking at the exact same data. We're just interpreting it differently. And they both work. The question is, which one's true? Yeah, sure, it would take 13.7 billion years for it to happen naturally over those natural processes. The question is, did it happen in those natural processes? We explained some of the issues with that in terms of creation. And if God created it, well, that kind of puts a nip in the bud for that. Here's some other things to look at. One of the issues we have with cosmic evolution are some strange anomalies we see within our observable universe. We'll get to this one at the end. But so there's blue stars. Obviously, blue stars burn what? I just said it, if anyone was paying attention. They're the hottest and the brightest and the fastest. If the universe has been around for 13.7 billion years, we shouldn't expect to see very many, if any, blue stars. Yet we still see blue stars still now. How are they still around? They should have all burned out, especially because everything's kind of cooling down now. Even though it's accelerating in terms of expansion, everything's long cooled, and it's even more cooling. Our sun is getting dimmer. Yet we still have blue stars that are the brightest stars in the universe. That's you would expect that to just go away, not to exist anymore, yet they still do. And people have different reasonings for that, but none of them really hold up yet. And we'll talk about those later. Comets. This is very interesting. You guys see comets in the sky, they pass by, and we talk about, this comet's going to hit the Earth, and it's actually farther from the Earth than the moon is, and we're all terrified about it. But comets are space debris. That is, things that hit each other, and they brained off during the Big Bang. They're spinning off still. They're still space debris. If the universe is 13.7 billion years old, how do we still have space debris? That doesn't make, that stuff should have been absorbed by a black hole, hit into a planet, absorbed by something's gravity, burned up in the sun's atmosphere, or I guess it doesn't have atmosphere, but burned up before it even got to the sun, burned up in some other planet's atmosphere, yet we still have it. Jupiter is still absorbing more of that space debris. That's kind of the reason we have Jupiter. It's just a giant vacuum. Which is very strange. Why do we have comets? Yeah, yeah. Exactly. Why is it still going around? Well, it should be done. How old is that thing? 13.7. Yeah, but exactly, yeah. That's why we still see the same comet, because it's still around, which is very strange. You expect that in the young universe, well, because, you know, it doesn't have time to get old yet, but we don't expect to see it here. The last one right here is the backward spin. So if you notice, every planet, and this is something I don't know how many people know about, but they all spin exactly the same way, which is counterclockwise or anti-clockwise, except for Venus. Venus spins clockwise. Very strange. Even though so they all spin around the sun, right? They all spin around the sun anti-clockwise. Even Venus spins around on its orbit around the sun is counterclockwise. Yet it itself spins clockwise, which is contrary to all these. You'll notice Uranus is kind of different. It spins almost horizontal, but still spinning anti-clockwise, horizontal. But almost, it's not fully horizontal, even though in that picture it looks like it, but it's still spinning clockwise. Let's go back. But Venus spins clockwise, which is very strange. In order for that to happen, something very strong, very big would have to hit it while it's spinning the right way and spin it the other way. The reason that is because of, what's it called? The law of conservation of angular momentum. That is, at the Big Bang, everything exploded outward, but it didn't just go out, it went out like this. So it's spinning, everything's spinning outwards like that. And as it spins outwards, the law of conservation of angular momentum means that it keeps on spinning. If you've ever been on those little playground merry-go-rounds, you spin somebody around. When they let go, they don't just go straight back, they go and they spin a little bit. Depending on how hard you hit them, they might spin a lot. But they'll spin out, and they keep that same momentum. Whatever way it was spinning, they keep spinning that way. Yet, you'll have something like Venus, which spins opposite. What hit it that did, I mean, maybe Venus is kind of small, right? Maybe something big hit it. We don't see evidence of that, but that's one thing. There's also another thing. There's a galaxy, a whole galaxy called NGC 4622 that spins the opposite way. That's not a planet. That's not a solar system. That's a whole galaxy spinning opposite to everything else. And there's multiple galaxies like that, which is interesting. How is it, what can hit a galaxy that causes that? Well, maybe it hit against a black hole that we just don't see, that's not even close to nearby enough. I mean, if it got close to the black hole, why didn't it suck it up? How did it make it go from this way to go to this way? I mean, how much power do you have to do that? It's almost like someone placed it that way and said, like, look at that, this is impossible. Who's going to figure this out? There's like little breadcrumbs that God leaves behind, I would say. But it's very interesting, those little anomalies that's like, cannot be possible in natural processes. They try to figure it out, try to explain it, but none of them work. They always say that, like, well, these are possible explanations, but we don't really know because none of them really work. But maybe later on we'll find some enough evidence and blah, blah, blah. Issues with estimates. We're nearing the end of our lesson today, I suppose. So a lot of this stuff is all based on estimates. None of this stuff is exact, right? We have, give or take, hundreds of millions of billions of years. So this quote says, "We know how bright a star looks, but to know how bright it really is, you have to know how far away it is. It is like a headlight a mile away or an airport beacon 10 miles away." So it's saying, based on those things, like an airport beacon is larger than a headlight. But if they're the correct amount of distance, like the headlight's right here, and the airport beacon's right there, they might look like they're the exact same distance away, because they're the exact same size from your perspective. And it says, "In the dark of the nighttime sky, with no reference points, it's pretty hard to tell. Taken together, the uncertainty in the observations and the uncertainty in the relevant theoretical physics probably lead to an uncertainty of 10% to 20% in our estimate of the absolute ages of the globular clusters." How do they know that those are the estimates? That's an estimate, just to say. It's very interesting. They know there's some error there, because we can't really tell. There's no background, and it's just black. It's all black all over the place. We don't even know what that is. It may be dark matter, antimatter, that kind of stuff. It goes on to say, "Even well-studied stars surprise scientists every now and then. In 2019, when the red supergiant star Betelgeuse dimmed, astronomers weren't sure if it was going through a phase or if a supernova explosion was imminent. It turns out it was just a phase. The sun also shook things up when scientists noticed that it wasn't behaving like other middle-aged stars. It's not as magnetically active compared with other stars of the same age and mass. That suggests that astronomers might not fully understand the timeline of middle age," meaning they don't know for sure. That we're all basing these things on estimates, based on observations that are not even fully conclusive. So there are some issues, but people accept this as fact. Evolution is a fact. Big Bang is a fact. Yet it's all based on observations that have error. We don't know for sure. In fact, we don't know that much at all. We try to explain it as much as we can see, but it's when you start to look at a lot of these academic papers I've been looking through, On the surface, you look up on Google, like, this is what it is. This is the fact. You look at the academic paper it references or the academic paper that the academic paper references, and they're like, it could be possible it's this way. We're not really sure. It's funny how that goes later on there. People are like, it's a fact. When you look at the people who are actually studying it, they're like, I don't know. And even scientists do this, which is kind of really bad. Some scientists will put out academic papers saying, look, we don't know. But they'll write a book for the masses and say, look, this is what we know. This is the facts. And because that's what sells. Oh, I want to know. The universe is 13.7 billion years old. We know for sure. And you look at the paper that they were the Dell evidence, well, we think it could be because based on these factors, but we don't know for sure. It's very interesting the way that goes. Okay, this is where we'll end today. I have this. It would work better probably if two people could read it. There's a girl part and a boy part. If anybody would like to read, I think we need a microphone. Araceli? We need a good reader. Just kidding. If you'd like to read, you could. Or does anybody like to read these parts? If not, I can take, Brother Jason. Okay. It's all one. Oh, Pepper's right next to you, if you could have her read that. I guess I can give you this. Or do we have a microphone over there that I can turn on? Somewhere. The pulpit. Okay, so this is a thought experiment to help explain some of the observational differences. We're going on green. I hope that one works. So the yellow part is the girl part. No, they're one thing. Yeah. So you guys will be sharing. You'll read everything that's not yellow or highlighted, and then Pepper can read everything that's highlighted. Don't look at me, look at them, or look at the candle.
Ready?
Yes, go ahead, please.
Chris and Lucy enter a building looking for Manuel. In a room, they found a note and a lighted candle. Chris looked at the note and read it aloud. Hi, it's 2:30, and I'm leaving to run some errands. I'll be back in a couple of hours. By the way, the electricity is out, so I lit a candle for you. Manuel.
Do you want to hold it?
Then Lucy said,
I'm going to say that part. Then Lucy said, I know how we can find out how long it's been since he left. Look, the candle has been burning since he lit it and has a significant amount of wax that's melted and dripped down. If we figure out what the rate is which the wax is melting and measure the amount of wax that has thus far dripped, we can work backwards to find out how long it has been since he left.
Chris said, why waste your time? The note says he left at 2:30.
Lucy said, don't believe everything you read.
Chris replied, look, I've known Manuel for a long time, and this is his handwriting. Don't be ridiculous.
Lucy replied, yes, but what does he mean by 2:30? A note like that is subject to interpretation. Suppose he was talking about another time zone or something, and so a short philosophical argument ensued about the note. However, Lucy prevailed and insisted on performing the measurement and calculations. A few minutes later, Lucy announced, well, I've got bad news for us. Based on the amount of wax that is melted and the rate at which the wax is melting, I can confidently tell you that it has been at least one whole day since this guy left. He is probably talking about 2:30 yesterday, and since he said that he'd be back in a couple of hours, we can assume that something happened to him and he's not coming back at all. So much for your note.
Just then Manuel walked in.
Lucy said, are you this guy, Manuel? What took you so long?
Manuel replied, what are you talking about? I left you guys a note saying I'd be back in a couple of hours. Hasn't even been that long.
Lucy said, never mind the note. I measured the amount of wax that has dripped off your candle and the rate which the wax was melting. I know you've been gone since yesterday.
First of all, that candle isn't burning anywhere near as brightly as when I first lit it. Second of all, I didn't light a new candle, but a used one. And thirdly, I used another candle to light this candle, and in the process, the wax from that candle spilled all over this one.
So you set up that candle to deceive us? To make it look like you left the room over a day ago, when in fact it's been less than a couple of hours?
Look, I left you a note telling you when I left. I never intended for you to conduct some silly experiment measuring wax dripping off of a candle to figure out when I left. I put the candle there so you guys would have some light.
Thank you. You guys can clap for them if you'd like. I don't know. That was really funny. That was good. The idea is someone left a note and said, this is exactly how things happen. This is exactly what's going to happen. This is how it's going to take place. And then we looked at the evidence behind and they said, is that really true? I don't think so based on this, based on this, based on this. He must have done it. And he comes back and he says, it's exactly like I said. The whole idea is to show that God has said in his word, this is exactly how things have come to be. This is exactly how I've set things to be. And people say, no, it can't be right. Based on the evidence, I think And notice what he said about the candle. I used a used candle, so it was already lower than it was supposed to be before. Some wax fell off of it. It was burning brighter, now it's burning not as bright. So there are certain things that they can't possibly, there's no way they could possibly know that. No matter how much observation you do, you cannot possibly know that. One of the instances, or the examples, is the rate of expansion of the universe. It's increasing in speed. If it's increasing, then how do we know if it's always been increasing? How do we know that if it hasn't been decreasing and then decrease, increase? How do we know it didn't stop at one point? How do we know that the rate has been constantly increasing, right? It's exponential. What if it wasn't? What if it was at a constant rate, something happened, and it went even farther? We'll look at that probably next week, talking about inflation, that it may even be possible that it expanded outwards, came in real quick, and expanded out again. So then how fast did it expand out the first time? How far did it go? We have no idea. In terms of light, again, if the light started there, maybe it takes that long, but what if it was extremely bright, then it got a little bit dimmer? What if things have been moving it away from it, so it's even getting farther, so it's actually things, we think it's been going this rate, but it's been moving at the same rate that it's been coming back, so it's actually farther than we even think it is. We don't even, I mean, based on their calculations, it could be even older than what they think it is. We have no way of knowing, because there's a lot of factors we can't observe. We have no possible way of saying this is must be how it is. Based on the observations, this is what it seems to be like, but our observations, like we looked at, can be extremely wrong. They can be extremely misguided. And so one of the reasons we hold to Christianity, and we hold to the Bible, we hold to God, we believe in God, is because he has things that we can prove. There are historical evidences that we can look at. We can think about things like we did tonight, about morality. Things like there has to be someone who always existed that suddenly created. There's things like that that's obvious. No matter what way you look at it, that must be the case. And if you look into that, find that line of reasoning, then who's this God? What has he said? You look at the stuff like the Bible, look at prophecy. Oh, this kind of proves that this person exists, and this is what he said, and he said what he meant, and he meant what he said. So we'll continue with more issues with the Big Bang and issues with cosmic evolution next week, if you guys want to keep on going with this. I trust me, it gets more interesting than this. This is just a lot of the groundwork you have to build towards until we get stuff like the flood, and we look at stuff like that, or dinosaurs. I love looking at that. But yeah, so I hope you know that there's two ways to look at the evidence. Just because there's evidence doesn't mean it says anything one way or the other. You have to look at the evidence, interpret that evidence. And there are people who interpret it incorrectly, and there are people who interpret it correctly, and there are people who don't know how to interpret it. And our job is to look at the same evidence. We may not all be scholars, like biblical scholars, but we can still look at the same Bible and read it and say, what does it say? Let's look at the Greek. We can break things down to smaller levels to understand. It's the same thing with science. We may not be astrophysicists, we may not be astronomers, and sometimes people say, I'm just going to leave the science to the scientists. Let them figure it out. Sometimes they don't know, and we'll look at, there's a video of that guy talking about stuff like that. Some people just don't know, and we think they know, because they prop it up like they know, but they actually don't. And so our job is to look at the evidence and try to break it down. Find other people try to break it down. Try your best to look at the same evidence that they're looking at, see, does the work hold up? That's why the whole reason we have peer-reviewed papers is because someone says, I know what I'm thinking, and someone says, hey, you missed this. Or actually, you write something that's false, but you're propping up as if it's not, which has been a big, there's a whole bunch of issues with that. People have done that. Any questions before we turn it back to Brother Anthony?
There's also funding for these things, yes. And sometimes the people that pay for it want a certain conclusion. And there's all this, people have a hard time being objective and completely honest. And then you have people who write garbage, submit it for peer review, and it's accepted. Mm-hmm. And they wrote it as garbage, and so it's people. Mm-hmm. And so there are so many ways that beyond, there's honest mistakes and then there's dishonesty.
We'll look at an example of that later on when we look at evolution with I think it's macroevolution, where people will have, even still now, they hold to a certain study that's been long disproved, and yet they still want to hold to it. Even very famous people still point to that, and like, it's been disproven. There's actually two of them I think we're going to look at. It's been disproven, and people still prop it up and go, well, because it agrees with what they say. And people do that in Christianity too. They'll look at certain verses and go, this agrees with my idea, so I'm just going to keep on holding to it, even though it doesn't, because everyone has biases, and especially when you have money behind it, it becomes very hard to push against that, because if they're not going to fund your research, then you're not going to be researching anything. At least you can research something, you do something you love, even though if you're doing some bad things with it.